Good morning, everyone, and welcome to our very first Tech Tuesday webinar from the Toronto local network of the Institution of Engineering and Technology. This is our first time around, so we hope that you enjoy the content that we have for you today. We are going to be using some of the IET TV content that they have available. This is a great resource that everyone can access. There's a bunch of free content for non-members, and there's also a bunch of additional content that's available if you do have a membership. Today's talk is going to be a short one on designing the things in the Internet of Things, and specifically looking at 5 key considerations. So in order to not take up too much of your time.
So this is all about the Internet of Things revolution. The idea is that increasingly devices are becoming connected to one another and to the internet, and it's going to create a whole world of exciting and interesting opportunities for consumers, for manufacturers, but it's got to be done right. It doesn't have to be rocket science, it's just got to be planned properly. Because of the manner in which so many of the aspects of technology are related. So it's really important that we have a good design from the start. This presentation is all about 5 key considerations. So why am I here to talk to you about this? And what experience have I got for developing things to the Internet of Things? I work for a company called 42 Technology in Cambridge, and we are a design and engineering consultancy. We take interesting problems, interesting ideas, and help to develop and engineer solutions to those people. So most people in the company, we usually have 2 or 3 projects on the go at any one time. We'll probably run a dozen projects a year, and that gives us a very high turnover rate of projects. Gives you a lot of experience running through things, and that means that when you make mistakes, you learn for next time, and the rate of learning is pretty high. So everything through from sort of early stuff, most of what we spend our day on is concept generation, proof of principle, product development, and design for manufacture. So that's the loop we go through over and over and over again. So every time someone comes to us with a problem, we just like to make sure that people understand the question that they're asking, and make sure that that's really drilled down. Not that I'm trying to sell the company, just sort of saying, having that high rate of feedback is quite important. The sorts of things that we do, industrial gas valves, we've done developments of space planes, sensor manufacture, sort of automation of those things, banknote handling, the thing in the middle at the bottom is a new train that I'm working on. And we've also done sort of power distribution for unmanned aerial vehicles. And on the Internet of Things side of things, we've done sort of a vast range of things, connected devices with home health hubs, smart meters, devices that communicate with apps, wireless communication systems with a whole range of protocols as well. So when you think of an Internet of Things thing, don't just think about a smartphone. It could be anything. It could be a lamppost that's a wireless node. It could be a flow meter in your house that looks at your water usage. Everything that connects up can be useful. So the Internet of Things, right, emerging network of millions of devices that talk to each other. It's opening up all these exciting opportunities. So for manufacturers, they're going to be able to build closer relationships with their consumers, because they're going to be able to track delivery logistics. They're going to be able to look at product usage. That's going to allow them to have better information so they can start to design better products next time. And it's also going to allow them to more efficiently monitor what they're doing in-house and managing their own in-house assets. For consumers, things like the connected home are becoming a possibility. Now that's going to be where we have effortless restocking of our kitchens, because our fridge knows what's inside it. That's where we have a house that automatically unlocks itself as we approach the front door. It's where lighting's turned up and down, everything's on demand, and this is all done in a smart manner. And so, wow, this is really exciting. Lots of cool stuff can happen for us. But, according to Gartner's hype cycle, and this is Gartner's hype cycle, after a innovation trigger, at the bottom left on the x-axis, comes the peak of inflated expectations. And this is the time where everyone goes, wow, we could do this, we could do that, we could do the other. So with 3D printing, people looked at that and said, we can 3D print sandwiches, we can 3D print body organs and cars, and I need a cup, so I can 3D print a cup. And you can do. But what we've since found with 3D printing, we entered the trough of disillusionment. We realized that actually some of this stuff's quite hard. There are technical demands. But we're starting to get onto the slope of enlightenment. We're finding niche applications where 3D printing does work, and it's got a real business case behind it. And as it reaches the plateau of productivity, we're going to continue to find more and more applications where it makes sense. Now, Internet of Things and connected home, I believe that's round about the peak of inflated expectations. What's going to happen is, in the next couple of years, we're going to hit a trough of disillusionment. Everyone's going to realize how hard this sort of thing is. And for a while, it'll just lie in the doldrums. But then we'll start to find applications where it works. We'll find applications where connected devices do make sense. Then people get used to the idea of using them within their home, because this is going to require new interfaces and new interactions with products. And once people get used to the idea of this stuff just happening, they'll be able to invest more faith in it. And then it'll start to reach the slope of enlightenment, and then eventually become quite a productive way of doing things. Now, from our own experience, it's often the most basic technical challenges which cause the most problems. And because we are a technology company and we invest in doing things like battery selection and writing the right algorithms and getting the right security, we like to focus people's attention on the basic sides of getting a technology to work. And a really good way of visualizing this is Maslow's hierarchy of needs, which many of you will have heard of. But in 1943, the American psychologist Abraham Maslow basically came out with an idea which says that people are motivated to achieve certain needs. And only when that level of needs have been achieved will you start to look for things on a higher level and a higher level. So on the most basic physiological needs, sort of sense, people will look for shelter, food, water, really physiological basic stuff. Once that's achieved, then they'll start to look for things like employment resources. They'll look out for their family, their own health. Once that's achieved, so on and so on, all the way up to the top where you hopefully start to achieve self-actualization, things like feeling worthy in your job, bounding out of bed in the morning, being ready for your day. In a similar way, you can build a hierarchy of Internet of Things needs. So physical needs are power. You need to have a battery. You need to have energy harvesting. You've got to have power going into this thing. Only when you can really say that you've answered those basic physical needs for your system can you then move on to the security and the connectivity and the data and so on. So what we've done is we've just picked out sort of 5 of these things, and just going to sort of talk through those now for a moment. So power. In situations where you're in, for example, a manufacturing plant, and you've just got power everywhere for free because it's in the walls, that's fine, that's easy. But a lot of the future devices that we're going to be talking about are going to be carried around. They're going to be portable. They might be in situations where it's not easy to access them, to give them power. So we could be talking about a device which is sitting on top of a wind turbine, which is monitoring the condition of the wind turbine, what it's been through, what it's doing, and sending that information back to the shore. Doing that in a smart way, which consumes a minimum of power, is very important. So today's wireless devices can be made to run for years on a single battery through the use of sort of low-powered sleep between tasks. So you want to have sensors on board which are able to sense what's going on with it, put it to sleep when it's not being used, wake it up when it is being used. Effective data transmission optimization is also important because sending information is expensive. And there's always a trade-off to be made between doing onboard computation to send a small amount of data and just pinging data up to the cloud and then maybe doing the processing up in there. And every design device choice that's made affects battery life to some extent. We're getting to a point with some battery technologies where we can almost say this number of computational steps consumes this much energy. This kind of wireless communication, depending on where you are in the world, what technology you're using, costs this much energy. And you can then start to budget. If you want to have a 15-year life on your battery, you're probably going to have quite a big chunky battery for a start, but you also need to be absolutely clear and certain from the outset as to why you're making certain decisions. So, as with all good projects, have a clear strategy, be clear about what your goals are. If you want something that has a high rate of communication, you'd better make sure that the amount of data that you're sending is quite simple and small. If you want to be more complex, more informative about what's going on with your product, then be prepared to have fewer and fewer things that you're saying. Okay, privacy and data security. Collecting information about people's location, their behavior and their health raises a lot of privacy and information security concerns. Security, if it's done right, is going to make for a less convenient deployment. It might use more onboard computation because you have to do encryption. Did I mention battery life? And it requires well thought out support infrastructure that needs to be reviewed and updated continuously. But if you don't do security properly, then it may well end up leading to bankruptcy and maybe even prosecution. So you can do things on the fly, nice and easy in development, but be absolutely certain that you are aware of the privacy and encryption requirements for the field that you are working in before you start, and that should be a clear part of your strategy. So communications, number 3. The way in which you get data from your low-powered device to the cloud, it might be achieved through a dedicated hub in your home. It might be through a smartphone. So when I go running on my running watch, I download all the data to my smartphone, and then my smartphone sends it to the cloud. Or it might be a home Wi-Fi router. But the most popular way of getting data from your device to the cloud might change in the next 3 to 5 years. The design decisions you make today might not be the same ones you would make in 3 or 4 years' time. So you need to be thinking about having the ability to remain flexible. We're working on a project at the moment for a train company that invested in putting sort of in-flight entertainment screens in the backs of seats. And just after they'd invested all this money in these in-flight entertainment things for trains, and they were counting on the advertising them, allowing them to recoup those costs, everyone got smartphones. And everyone stopped looking at the screen in front of them on the seat and started looking at their smartphone. And so no one wanted to advertise on these things. They took a massive hit because they didn't think about the emerging technologies that were coming down the line. And furthermore, as devices get cheaper, the number of devices you're going to have, for example, in a house, trying to talk to the Wi-Fi router or trying to talk to your dedicated home hub is only going to increase. When you've got your barbecue meat temperature sensor and your fridge that knows what's in it and the floor that knows how much you weigh, all shouting at the home hub, trying to get this information back to the cloud, there's an awful lot of things for it to listen to. And again, if you want to increase the priority of your device, you might have it shout more frequently. But if you're looking for low power, again, battery life comes into play. So you've got to be a bit careful with that. Platform choice, number 4. With low-cost hardware and development starter kits becoming more widely available from lots of different vendors, the barrier to initial device prototyping is getting lower all the time. You've got a lot of players like Apple bring out HomeKit, Google's have brought out Brillo and Weave, and what they're all doing is they're all trying to be the winner in the battle for the platform. In the same way that back in the 80s there was the battle between Betamax and VHS to be the de facto go-to platform. In the same way that Microsoft won the PC battle in terms of being the de facto PC system, and Android's arguably won against iOS in terms of being the wider, arguably, smartphone operating system. They're all out there, they're all competing for this, and you need to be aware of your exit strategy when you're creating your wireless product. If you want to maybe sell out to a big company somewhere down the line, you're going to want to build your entire system, your entire strategy around a operating platform which is compatible with the people that you're likely to be selling out to. So if you're going to go sell to Intel, make sure you're using an SAP sort of platform. Doing that research up front and making sure you know what it is you're designing for. That's the important thing. Just be aware, word of warning, when it comes to platform choices, the new platforms coming out all the time. There are still people who don't think it's too late into the game, which means there's a lot of bleeding edge operating technology out there. Typically, bleeding edge technologies are fairly poorly documented. And if you're doing this, then you will not delight your software engineers because they like to have well-documented systems. And then finally, sensor design. Internet of Things devices are usually expected to have low-cost sensors. Now, low cost means that you've not invested a great deal in terms of the steps involved in the manufacture. So if your sensor that you want to use requires calibration before it leaves the office, that's going to add cost. And therefore, as much as possible, people are going to try to avoid doing those calibration steps. But still, they're going to want to have full functionality over long periods. They're still going to want to deal with the challenges of temperature, humidity, shock, dust. And that means that the devices, you're going to have to design them to be able to self-test, to find faults within themselves, potentially resolve those, and be foolproof in use if the total cost of ownership in the business plan is to be achieved. So that's 5 things. Power, and as you can see, power has an effect all the way down through these. Privacy and data security, very important. Communications and power, very closely interlinked. Platform choices is somewhat abstracted away from the others, but you know, it's something that you want to decide on right at the outset. And sensor design as well has an effect on cost and potentially power as well. So with a bit of luck, cheesy slide to finish off with. If you can get your system design right from the outset, and you can be sure as to what your strategy is, be sure as to what the tactics are for achieving that, and every time you make a decision, it tallies with what you originally set out to do, although you should be reviewing that plan constantly, then what you can do is hopefully get out of the trough of disillusionment pretty quickly and start on your way to the slope of enlightenment. I told you it was cheesy. Right, thank you very much.
Okay, that's essentially it from the Toronto Local Network for today. Thank you very much for joining us. We hope that the content was useful. If you do have any ideas of what you'd like to see in any upcoming webinars, please do let us know either in the comments or, of course, on the IET communities via our Twitter feed or Facebook or LinkedIn or any other method. Just let us know what you'd like to see. Thank you. Have a great day.